Now that we looked at focus and directrix when the parabola is at the origin, let's look at a focus of a parabola when the vertex is changed. So let's remember the standard equation of a parabola with vertex at origin is 0, 0. So that is y equals 1 over 4p times x squared. Our focus is at 0p, so whatever that p is. And then our directrix is y equals negative p, so opposite of where the focus is. So the vertex of a parabola is not always at the origin, and so as in previous transformations, adding a value to the input or output of a function, it translates its graph. So just so you can see what this looks like, we have y equals 1 over 4p times x minus h squared plus k. So it looks like our vertex form. Our focus is h, comma, now it's at k plus p, it just shifts. And our directrix is going to be y equals k minus p. Our axis of symmetry is going to be at x equals h. Okay, so let's try, let me give you a picture of this. Let's just say our axis of symmetry is here at x equals h. Our parabola, we'll say, is maybe somewhere over here, so it's shifted to the right, up a little bit. And then our focus is here. And that's at h, and then k plus p. So it's shifted to the right and then up from the vertex. And then our directrix is p units below it. And so that's just going to be k minus p. Now, this is just something that I want you to see, not necessarily something that's going to be tested on, but just to see how to do these types of problems. On the right, it's a similar graph, just upside down. Okay, so let's identify the focus, directrix, vertex, and axis of symmetry, then we're going to graph it. So what we can read right away is our h and our k like we did before. Our h is going to be a positive 3, the k is a 2, so we know that the vertex is at 3, 2, so right 3 up 2. So that's our vertex. We know it's positive, so it's going to open up, so I can give you a little bit of a curve there. And then we need to find p. So a is the number in front, so kind of like what we did before, 1 over 8. So a equals, remember that's a equals 1 over 4p. So we're going to set that equal, the 1 over 8 to 1 over, we're going to set the 1 over 8 equal to the 1 over 4p, and then we cross multiply. So we get this as 8 equals 4p, divide by 4, so p equals 2. So the fastest way to do this is just knowing that p is 2, you move there from the vertex. So the vertex is here, we're just going to move it up 2. So the focus is at 3, 4. Okay, so just count it. The directrix is going to be 2 away from the vertex, but on the opposite side. So it's going to be here. So therefore, directrix is y equals 0. The axis of symmetry is the x value of the vertex. So the axis symmetry is here. And the x value of our vertex is here. So it's x equals 3. We could talk about our transformations. So we know that it's right 3 and up 2. Okay, and I know it's probably shrunk a little bit more, but let's just talk about where it moves right or left, up or down, and so forth. So right 3, up 2. Then we have to graph some points, 1 over 8. So we would go 8 to the left and then 8 up, and there's not enough room on there. And if we were going to plot some points, a nice number to plug in here from our vertex, that would be 4. Okay, so because 4 squared is 16, so I know that would work out nicely. So if I plug in a 4, just so you can see what it looks like, I'm going to multiply. So we have 1 over 8 times 4 squared is 16. And then 16 over 8, well, that's just 2. So if I plug in 4, my next point is 2 from my vertex. So I'm going to go right 4 up 2 or left 4 up 2. Notice it's kind of in line with my focus here. And so that's actually the end of our graph. So here's our focus. Our vertex is here at 3, 2. And there is our graph. So see what you can try in this example right here. Identify the focus, vertex, and axis of symmetry of the parabola. describe the transformation. And so what you would do is, let's see, try to find A, right? Identify A. So A is here. And then you remember you set that equal to 1 over 4p. Identify where the vertex is just by reading it. And then once you find what P is, then see if you can figure out the focus and directrix as well. So pause the video and try it out. Okay, if you tried this out, you would have gotten this graph here, and just sketch it. I know that you can't really sketch 1 over 12 on here, but your A value is 1 over 12. You set that equal to 1 over 4p, and you find that P is 3. So P is 3, and our vertex is at 1, positive 3, so write 1 up 3. So we know that P is 3, so I go up 3, and there's my focus. Then to get the directrix, it's 3 below, 1, 2, 3, and I draw a line there, and then that's y equals 0. The axis of symmetry is the x value of the vertex, so that is, x value of vertex is right here, so that's x equals 1. Describing the transformations, just say that it's right 1, up 3, and that's it. So the last thing is that this last part over here, the homework is below. So you'll have to do just these problems down here. Identify the vertex, focus, directrix, axis symmetry of the parabola. You could try to graph it if you would like to see if you can do that. And then 55 and 56, write an equation of a line that passes through the given point. So this is review. And so remember that you need to use the distance, you need to use the slope formula, x1, y1, x2, y2, m equals y2 minus y1 over x2 minus x1. And then in order to find the equation, you're going to use point slope. Y minus y1 equals m times x minus x1. Okay, so you'll do that for both 55 and 56. It's just a good review on writing an equation of a line. And so that's it. So those for homework. I hope this helps. Thanks for watching.